Live from the Icebox Studio in Montgomeryville, Pennsylvania. It's the Bill and Corey Show. I'm Bill.
And I'm Corey. And I just want to say, may the 4th be with you.
Oh, thank you.
I was thinking this morning, Bill, can you imagine the amount of compressed gases and spec gas equipment required to run the Death Star? Can you imagine getting that contract? That'd be a pretty good one.
That'd be pretty good. I think we got a sales guy working on that now.
All right, good.
Okay. First question for today is for Corey. And Corey, I don't know what the
called,
question
It's called Corey's question. It was a phone call question yesterday, and it was one of those things where it was interesting, and you had to ask a lot of questions to get to what they were trying to do, but we finally got there, I believe. And so it was an older, he said it was a regulator from the 1980s, so it was an older regulator, but it's a dual-stage regulator being used as a line regulator, which is odd. And he specifically mentioned how he had it being piped away from one of the ports, and specifically this one, when I figured out. And he wanted a similar regulator do the same thing. He had ordered our line regulator, our 3450 line regulator, which only has 1, 2, 3 ports. This one, 6 ports. And so he's asking, where am I supposed to pipe out so I can protect downstream of the regulator just in case the regulator goes? So the gentleman that was working on this system said he had not designed it and didn't know why the original guy put it this way, and I couldn't figure it out either because he was thinking that, so this port right here is the Interstage port.
That's a loose fit.
Yeah. Okay. So of course I have to play with it as I do it. And so this is the Interstage part, which if you know what a dual stage regulator has, 2 regulators in one. The first stage, which this would be, this is what this would be protecting after the first stage, so the gas inside. And it only is set to about 500 psig, typically, around that area. So this gentleman had 100 psig outlet. So this little relief valve is not going to be able to protect downstream of this because if the first diaphragm is creeping, causing it to go up, this will be released. But if the second diaphragm is creeping at, say, 300 and not releasing this could still see that higher down pressure. So this is not a safety device for your downstream pressure.
Right, and you can obviously install.
You can all have it. It will bring the pressure down, so it will not see cylinder pressure downstream, so it will protect from that. So that's the only thing.
You're typical with a dual stage regulator. You're typically going to see if you get contaminants on the inlet, you're going to see the first. You could, not typical for it to happen, but if you're going to see a failure, it's most likely going to be in the first stage, not the second stage.
Yes.
But you should always. If you need to have a relief valve to protect your equipment downstream, then you need to have a relief valve.
You can't. You don't want to rely on the regulator to do that.
Okay, that's good. Okay, second question is for me. It says, does a CGA 240 need a washer?
Simple yes or no question. Let's go.
It's done. Okay, we're going to the next question. No, it's a lot of people are like, what's a CGA 240? I mean, you're probably used to the regular one, CGA 580, 350, 540, 320, and such.
The logical numbering system the CGA Association came up with.
So the CGA 240 is for ammonia service, and it is a 3/8/18 NGT. Now, and if you had it's like, oh, don't you mean NPT? Well, NPT is National Pipe Taper, and the NGT is for gas services, National Gas Taper. So it's this is like a 3/8" NPT thread, but it's got a little bit more thread on there because you're going to be making and breaking this more often, and things will get kind of worn down. So it gives you more play and better sealing conditions over time. So this does not require a washer. A washer is not going to work on it because it's going to seal on your pipe threads. What's kind of interesting about this is because it doesn't have a swivel joint. If you put this on a flex hose, it's going to be hard because you have to have a swivel joint somewhere in the flex hose. This is just one. This is more of a rare fitting for ammonia service. Your typical ammonia cylinders. This is a CGA 705. It's kind of got a big nut. That has a washer on it. Now, if you have a CGA 705 valve, you could have it could be probably most likely threaded for a CGA 240 fitting. That's why the nipple's kind of big. So, but you want to, the CGA 705 does have a washer on it. The CGA 660 is kind of like a catch-all CGA fitting. This has a washer on it. That's for ammonia service. Also, ammonia has some yoke fittings on there, and that would be like a CGA 800 or 845, and they're kind of these really, we don't have one in stock here, but they're these pretty big size yokes that fit over the whole valve, and it pretty much does the same thing as this kind of fitting. So yeah, so that's your ammonia service CGAs. Okay. And next question is for Corey.
Go ahead, start her
Okay. Yeah, and they're asking about someone received a package that wasn't vacuum packed. If you can see, it's loose. Okay, so you want to show them what the...
And this well, yeah, no, I'll get to it. Just
okay. So yes, they had, it wasn't vacuum packed. And
so they had a question about packaging for our gas purifier type 451. It is for taking moisture out of your process. Inside here, there's magic beads. 13x mole sieve is what I do believe it is. And so it takes moisture out of your line. So if you have a bag that is a little bit loose like this, that means there's air in your bag. And what does air have in it a lot of times? I mean, unless you're living in Arizona, it's got some humidity in it.
I mean, you're not going to have a lot of moisture in there.
No, but you won't. But still,
that will tell you the bag could have been popped.
Could have been popped, yes.
Yeah, there's probably a leak in the bag.
Yes, and I mean, not a lot of air gets in it, but when it's exposed to air, it can it can take away moisture removal capacity if it's exposed to air. So the one that you want, and you can clearly see this, just like the meat at the store, vacuum sealed for your freshness.
Yeah, you can tell it's pretty tight.
Yeah, but we don't use clear bags. We don't want to show that off. So do not use a loose bag. Use a tight bag.
And you just send it back.
Yeah, send it back and we'll replace it. Yeah, no problem at all. That's not on you. That's on us or the shipping company. We don't know.
Yeah. Okay, or they could have messed it up. Okay, now we have a rotameter question here. And we'll get a graphic, but don't put the graphic up yet.
Hold on.
There's a customer, and I have this. They have Matheson 603 E500 tube for methane measurement flow. It says I have a data sheet for 50 psi, but my line pressure is 150 psi. How do I correct the pressure differential? I want to show a little bit about what's going on here. Now, what's important is the pressure that's inside the tube. So I'm a little confused about their pressure. Some people get confused about it. This is a typical rotameter with a valve on the inlet. The outlet is to atmospheric pressure. So if you have 150 psi coming in before the valve, past the valve is going to be atmospheric pressure. So that's what you have to check is what's the pressure inside the tube, not what's the pressure is going to the rotameter. And that's the chart you need to use. Now I'll just show you that I'll flip the tube around. You can get the tubes, the rotameters, FM 1050s, with the valve on the outlet. And that's what you want to do. We just loose fit this. You would use a wrench to tighten it in.
But real quick, could you do that to a rotameter and still use it?
Yeah, you'd have to flip the label around because the label would be upside down.
I just want to make sure people...
So that's what's nice about the tube cube. It's a little jack screw there, and you just have to loosen that, pop it out, flip it around. Now you have a valve on the outlet.
There you go.
And your label's upside down.
Easy peasy.
Yeah, and then here, if you have 150 psi, then you want to have a chart that says, well, we don't have it for 150 psi. So it's, so it's the pressure inside the tube. Got a video that talks about this. It's read a rotameter right.
And there's a really good just how-to colored illustration on our rotameter website that is does a really nice job too explaining it.
Yes, yeah, and explains about the pressures.
That's how I first learned when I started
working. Hopefully this is where we want to put up the graphic for the pressure correction factors. And I want to pull it out too. Yeah, so hopefully up on the screen you'll see the pressure correction factors. And this has it's got a nice little chart there, and it's got formula at the bottom telling you about how to calculate the correction factor for the pressure in your tube. So you took the one axis will have the pressure for which the rotometer is calibrated. So this is, you'd go down and be halfway down and be 50 psi. And then you'd look across for 150. We don't have 150, we got 120 and 140.
140 and 160.
And yeah, 140 and 160. I'm sorry, 150 is between 140 and 160.
It is.
So you have to extrapolate, which is, in this case, 150 is halfway between 140 and 160.
Easy extrapolation.
So yeah, you take the average of those, and then you're in business. So yes, we have a nice rotometer pressure correction factors, and that'll help you get the correct flow in your rotometer. Now that is all the questions we have for this week. Thanks for tuning in. We'll have another episode next week at 10 a.m. on Thursday. And I don't see any questions that came on YouTube chat. But next week, tune in live and you can YouTube chat us questions.
Thank you for watching, and set your VCRs.